Next, we're going to take a look at how to multiply radicals, or other expressions that have radicals in them. We'll start with the straightforward one, root 2 times root 8. This is just a review of the product property. And when I multiply radicals, I'm going to take the coefficients, in this case they're 1s, and 1 times 1 is 1. And then I'm going to take the radicands, 2 times 8 is 16, and the square root of 16 is 4. And again, we usually don't write that coefficient of 1 because 1 times anything is itself. So we just get 4 for that first problem. Now we'll move on to something a little trickier here. Immediately, I'm hoping that you're thinking about distributing because of these parentheses. And you could think of this as 1 root 3 if that helps. You could think of this as 2 root 1 if that is helpful. That way you can see what it is that you're multiplying. Remember, we're going to multiply the coefficients and multiply the radicands. So first, we're going to do 1 root 3 times 5 root 3. 1 times 5 is 5. Root 3 times root 3 is root 3 squared. Then we're going to do 1 root 3 times 2 root 1. 1 times 2 is 2. Root 3 times root 1 is root 3. Remember that a square root and a square are inverses, so they're going to cancel each other out. And 5 times 3 is 15. So the solution to our next problem is 15 plus 2 root 3. Now for this one, we did one similar to this earlier in the year, but without radicals. Remember, when you square a binomial like this, it just means that you're multiplying it by itself. So the definition of squaring something is multiplying it by itself. So your first step is going to be to rewrite the problem. Instead of 1 plus root 5 quantity squared, you're going to rewrite it as 1 plus root 5 times 1 plus root 5. And then we will distribute. You could also use the box method for this if you prefer that way. 1 times 1 is 1. 1 times root 5 is root 5. Root 5 times 1 is root 5. Root 5 times root 5 is root 5 squared. All right, these middle two terms are like terms. 1 root 5 plus 1 root 5 is 2 root 5. And a square root and a square are inverses, so they undo each other. The square root of 5 quantity squared would just be 5. And now that makes these like terms. 1 plus 5 is 6. And my final answer for this question would be 6 plus 2 root 5. Now we've got just one more multiplication problem for you. Anything that looks like this form, a minus root 2 or a minus root b and a plus root b. If you have one with a plus and one with a minus, but it's the same expression otherwise, so the constant parts are the same, the radical parts are the same, these are called conjugates. And something interesting happens when you multiply conjugates. So let's take a look here. 1 times 1 is 1. 1 times root 2 is root 2. Negative root 2 times 1 is negative root 2. And negative root 2 times positive root 2 is negative root 2 quantity squared. Now, just like in the last problem, these middle two are like terms. 1 of something minus 1 of something is 0 of that thing, though. So that's 0 root 2, and 0 times root 2 is just 0. So those two terms end up canceling out. And we still have this one. And we've got the square root of something squared. Those cancel out as well. They're inverses, so that simplifies to just a 2. And I get 1 minus 2, which is negative 1. So we started off with this somewhat complicated problem, 1 minus root 2 quantity times quantity 1 plus root 2, and we got just a simple answer of negative 1. That's going to happen any time that you multiply conjugates.